The fourth law. A ray incidented obliquely to the principal axis towards a point P. So basically they're talking about this is your center of curvature focus and this is P. So the language is simple. All they're trying to tell is if a ray falls at point P, right? Something like this. So this is your point P. If the ray falls over that, okay, again, this is 3-dimension, remember, but we can draw only 2-dimension. If a ray falls in some manner like that, what happens? What do you think happens? How can we draw normal at this? And where is the radius for point P? This is the center. This is point P. Where is the radius? This very thing, right? So if that is the radius, okay, just a second. One second. Yes. If this is the radius, let me do it again. If this is the radius, it's very thin. Where will be the tangential line? Something like this. Okay, not like that. Something, no, not that also. Something like this. Okay, let me do it over here actually. So if I have a ray falling at the pole, this from here, let me use red color actually to draw the radius from the center to the pole. I'm drawing the radius. So if I have to draw a plane, tangential line actually, it will be something like this. So basically this is your 90 degree. So what do you think happens? Think about a plane mirror. Forget about the curved mirror. Okay, something like this. So this is your same scene, but 3-dimension. So with respect to the red line, that is your principal axis, I'm going to draw a, not that, this. Okay, a mirror which is perpendicular to the just a second, I'm trying to perpendicular to the principal axis. Okay, let me change the color also. Now is it visible? So the principal axis and this mirror are perpendicular to each other. So the light is falling on the mirror in something like this, in some manner like this. Let me push it a bit forward. Okay, so what happens? Simple. This is basically your normal. Let me show it over here. This will act like your normal. So this is your what? Angle of incidence. So with respect to this, if I happen to draw a reflecting ray, the angle has to be measured. The reflected light has to be measured with respect to this very line. And so that will be your arc. So basically, your principal axis acts like a normal. Okay. So with that being the normal, angle of incidence is equal to angle of reflection. As simple as that. Make sense? So basically, we are looking at cylinder plane. This. That's your answer. Okay. Right. So that's how it will actually look. So now, how do you put it on a paper? I'm sure you will be able to figure it out now. It's quite simple. Same thing. Draw a straight line. Mark 0.36 centimeter apart. Draw an arc. Then you draw an incident ray at the pole. So on and so forth. Let me show you guys the video. So step 1, mark 0, 3 and 6. Next is draw an arc of 6 centimeter radius. So that's a mirror, right? So next step is to draw the incident ray. So measuring the angle of incidence. So this is around 20 degree. Next is your angle of reflection. That too is 20 degree. Right, that's it. Basically, that's your diagram. Okay. Yes, the arrow has to be written only to indicate which is the incident ray and which is the reflected ray. So confirmation, you can clearly see this is 20 degree. That's your reflecting angle, and that's your incident angle. That too is 20 degree. Okay, so the logic is quite simple. At the point of incidence, in this case, the pole, right? So I'm trying to draw the mirror actually. That I didn't find to be very convenient, you know. Then I thought it's okay. I mean, I'll do it the tricky way. Actually, we have to use a scale and set square together, then draw a perpendicular. But I'm using some trick. That's your plane mirror, which is perpendicular to the principal axis, which in our case is normal as well, right? So basically, that's your entire funda. Okay, so coming back to the screen, you guys have to pretty much write all of it. Again, once you write it and you guys are done. So this is your basically your answer. Don't forget to draw the arrow. I think that's it. Yeah. So this is equal to this. I is equal to R.